Okay, here we have our notes for Algae 5. Our question is to determine whether each set of lines is parallel, perpendicular, or neither. Parallel in math, when I talk about parallel lines, it looks like two lines that are just running exactly in the same direction, like next to each other, like those two lines that I'm drawing right now. The mathematical sign that we are going to use for parallel lines pretty much look like parallel lines, two lines that are just drawn next to each other. So whenever you see this, you know, oh, okay, this is parallel lines. To be parallel, a line and another line have to have the same slope. So when I have two equations and I need to prove if they have parallel lines, I will just check, is my slope the same as it is on the other line? As soon as we can say, yes, the slope is the same, we can say mathematically those lines are parallel. So if you look at number 1, my slope in this problem, remember m is the slope, is 2. And my slope for this line is also 2. And because both slopes are identical, we can say those two lines are parallel. They are parallel lines. Okay, so remember, same slope means parallel lines. Perpendicular, the word mathematically means two lines that intersect each other in a 90-degree angle. So 90 degrees. I would form a right angle right where they meet with each other. The mathematical signs for perpendicular lines look like perpendicular lines, two lines that are meeting in a 90-degree angle. And the slope is the opposite reciprocal. So reciprocal, if you remember from fraction, if I flip a fraction upside down, so let's say I have 1/2, the reciprocal of 1/2 is putting your denominator and your numerator and flipping them around. So the reciprocal of 1/2 is 2/1, or just 2. But we also want to make it the opposite. So if the one number is a positive, then the other number has to be a negative. So the opposite reciprocal is used when we're having a perpendicular line, which means one is positive, the other one is negative, and your fraction is flipped upside down. So for example, let's say I want to find the opposite reciprocal of -3. So this is a whole number. So how do I flip a whole number? In this case, we know any whole number could be written as a denominator of 1, which then the opposite would mean we're going to flip the 1 and the 3 around, making it 1/3. This one was negative, so this one becomes positive. The opposite reciprocal of -3 is positive 1/3. So if we're checking on our first problem, our slope on my first line is 5/7. The slope on my second line is -7/5. So let's check. Do I have an opposite reciprocal? I have a positive and I have a negative, and I can see when I flip the 5 and the 7 around, I'm going to get the 7/5. So in this case, we could say, yes, those two lines are opposite reciprocal, and therefore those lines are perpendicular. If I would graph those two lines, they would actually meet in a right angle. Let's do some more. In this case, number 3, we don't know right away what my slope is in this case. I have to first rearrange my equation to make it equal to y. So I would subtract my 3x from both sides, which then I would give me a -3x minus 12. This is my first equation. And I'm going to rewrite the second equation over here. So let's check, do I have parallel lines or do I have perpendicular lines, or maybe do I have neither? I'm going to check my slope. So the slope on the first line is -3. The slope on the second line is -1/3. So they are reciprocals of each other, but because both slopes are negative, they're not opposite reciprocals, they're just reciprocals. So in this case, I would have to say those lines, they're not neither. They're not parallel, they're not perpendicular, they meet somewhere, but they're not special lines. In this case, you just say neither. Okay, so there are some additional questions on number 5. Number 5 I will do in class on Tuesday and on Wednesday. So it's a lot of notes for your number 5. Computer is not working. I've tried to move it. Okay, but let's first check, find the x and y intercept of each line and then graph these points. So for x and y intercept, let's go look. What is an y-intercept? We already know any time that I have a point on my y-axis, anywhere here, it doesn't matter, those are all called y-intercepts because they are laying on the y-axis. Let's think about what would be the coordinate of this point right here. The x-coordinate would be 0, and the y would be 1, 2, 3, 4, 5, 6. So the coordinate of this y-intercept would be 0, 6. What's the coordinate of this point right here? It is 0, 2. What about, let's make it over here. What's the coordinate of this point right here? It is 0, -1. What about the y-intercept over here? It would be 0, 1, 2, 3, -4. What do we see happening when we talk about coordinates of the y-intercept? Now we see anytime I have a y-intercept, my coordinate x is always 0. So I know for a y-intercept, in this case, if I want to find a y-intercept, my x is always going to be 0. And then a number behind it, that's going to be your y-intercept. Let's think about, okay, what is an x-intercept? Let me erase this all here. So an x-intercept means where does the line cut on the x-axis? So in this case, here could be an x-intercept, or this could be an x-intercept, or this could be an x-intercept. Let's think about the coordinates from an x-intercept. So in this case, it would be 1, 2, 3, 4, 5, 6, and the y-coordinate is 0. This point right here has a coordinate of 2, 0, and this coordinate over here has a coordinates of -3, 0. So what do we see happening on an x-intercept? We see that my y in coordinate is always 0. So I have a number, but my y coordinate is always 0. This is very important that you remember this, that any x-intercept has a y coordinate that is 0, and any y-intercept has an x coordinate that is 0. So you want to absolutely write this down for your notes. Now let's go find the x and y coordinate of this specific line. It is fairly quick and easy to find an x and y coordinate when the line is given in the standard form. So for example, this line is given in standard form. Let's go find it x and y. Let me erase this here. I hope you have written it down. So if I would plug in a 0 for x, what happens to this whole term if I make my x coordinate 0? This whole term becomes 0, only leaves me with 3y equals 12. To solve for y, whatever your y coordinate is, means we're just going to divide by 3, which means my y coordinate is 4. So what did I just find? If my x coordinate is 0, then my y coordinate is y. Now this is your y-intercept. We said anytime my x becomes 0, this is your y-intercept. So 1, 2, 3, miscounted. So 1, 2, 3, 4. Here's your y-intercept at 0, 4. Now, let's make our y-coordinate 0. If I make this piece 0, so if I say my y becomes 0, this whole piece drops out. I can now solve for x. 4x equals 12. I divide by 4. X equals 3. And what did we say? Anytime my y-coordinate is 0, we just found the x-intercept. So this point right here at 3, 0 is your x-intercept. These are 2 points that are going to lay on this line. So I can actually graph out of standard form fairly quickly by finding your x and y coordinates, and then I would just connect my dots with a nice ruler, and I have my line graphed using the x and the y intercept. Okay, let's do another example together. Let's make x be 0 again. So if this whole piece becomes 0, then I only have 5y equals 15. So if x becomes 0, I'm going to divide by 5. My y becomes 3. This is your x-intercept, your y-intercept. 1, 2, 3, right here. If I then make my y 0, so this whole piece becomes 0 because 5 times 0 is still 0, leaves me with x equals 15. In this case, I'm going to run out of space. 1, 2, 3, 4. Let's say it's somewhere over here. We have a really flat line. Yeah, that was pretty bad. But with your ruler, you'll get the picture. Okay, so your x-intercept and your y-intercept are fairly easy points that you can use when your line is given in standard form. You can calculate x and y-intercept fairly quickly and easy to find 2 points to be able to graph the line. And this is it, I think. Yes, this is it for your LG5.